Hello everybody, thanks for tuning in. This homework is the beginning of our new unit about logic and deductive reasoning. It's due on Tuesday the 11th for everybody except if you are in 5th period, it's due on the 12th, our red day. Alright, we've got a few definitions to get through. So our first one is our hypothesis. The hypothesis is the first part of a statement. And it always has if, the word if, in front of it. So you might recognize hypothesis from science class when doing an experiment. This is going to be like math experiments. So after our hypothesis has to come the conclusion. What's going to happen next? So the conclusion is the second part of a statement. And the conclusion has the word then in front of it. So let's take a look at this example. If it is noon in Virginia, then it is 9 a.m. in California. So our hypothesis is it is noon in Virginia. And our conclusion is it is 9 a.m. in California. So the hypothesis and conclusion do not include the words if and then. They're just the little statements that come after it. Also, if you take a look at this, we said that P equals it is noon in Virginia because P is the symbol for hypothesis. And Q is it is 9 a.m. in California because Q is the symbol for conclusion. So all of these definitions are going to have symbols associated with them. So next we're going to talk about the conditional statement, which is the given statement with a hypothesis followed by, you guessed it, the conclusion. So if we look at our example here, if two angles are vertical, then they are congruent. So first I want to figure out what my hypothesis is. So P is two angles are vertical, and Q, my conclusion, is they are congruent. So now the conditional statement is if the hypothesis, two angles are vertical, then followed by the conclusion. They are congruent. So your conditional is usually that given statement, the if followed by then, the hypothesis, then conclusion. So our symbolic form for this is P and Q, and in the middle we put an arrow to show that it's if P, then Q. Our next definition is the converse, which is a statement whose hypothesis and conclusion are switched. So using this same example, we have our hypothesis and conclusion. They are the same thing as what we got from these examples. But the converse statement is going to use this hypothesis and conclusion and just switch their order. So it just flips it. So if I write my conclusion first, two angles are congruent, then I write my hypothesis. They are vertical. So our symbolic form for a converse is Q, since our conclusion comes first, and then P, and you guessed it again, an arrow goes through the middle. So the arrow is just indicating that the statement is Q, then P. All right, up next we have the word negate. You might see this as negation as well. So negate is to create the opposite of a statement. So your big key word for this is going to be the word not. So this statement here, a number is divisible by 3. The negation, the opposite of that statement, is a number is not divisible by 3. Statement number 2, two angles are not supplementary. Well, this already has the word not, so if I need to put the opposite in, I could write not. So two angles are not supplementary. That sounds a little silly. So if there's already a not in a statement, you just remove the not, and that makes it the opposite. So two angles are supplementary. All right, moving on to just a few more definitions. You guys are doing great, I'm sure. Next up, we have the inverse. So the inverse is a statement whose hypothesis and conclusion have been negated. So this is why we introduced negation up here. So if I look at my example, we still have the same hypothesis and conclusion as we had in our above example. But I want to make not P and not Q. So this little squiggle line here is the symbol for not. I'm going to write that up here. Squiggle is the symbol for it. So not P is going to be two angles are not vertical. And not Q is they are not congruent. Choose my little symbol for congruent there. So the inverse, if two angles are not vertical, so this is just the negation of my hypothesis, then I have the negation of my conclusion. They are not congruent. So the symbolic form of this is not P and not Q, and in the middle I have my arrow. If not P, then not Q. Alright, next up our contrapositive. That is a statement whose hypothesis and conclusion have been negated and switched. So you switch the order and you negate them. So it's kind of the combination of an inverse and a converse. So our contrapositive is going to be if not Q, if two angles are not congruent, then not P. They are not vertical. So our symbolic form for the contrapositive is not Q and not P with an arrow in the middle. So if not Q, then not P. Alright guys, flip it over. We just have a little bit more to do. All of these are examples for you to do in class at the top, but let's talk about logical equivalence really quick. So all of these statements we've just defined, they're all going to be either true or false. So if you tell your friend something, it's either true or it's false. If it's false, they're probably going to ask you to prove it with a counterexample. So if I look at these two examples here, if two angles form a linear pair, then they are supplementary. Well, we just did this unit, so two angles that are a linear pair are on a line, and we know those equal 180, and supplementary means equal 180, so then this is true. So this conditional statement is true. But if we look at this one, if a number is divisible by 3, then it is odd. So 9 is divisible by 3, and 9 is odd, so this could be right. But what about the number 30? 30 is divisible by 3, right? 30 divided by 3 is 10. But is 30 odd? No. 30 isn't odd. So since 30 isn't odd, that is a counterexample to this statement. So this statement is false. So what you will do down here in class is write your different statements for this given conditional and figure out if they are true or false. Before we get to that, we just need to fill in these blanks. A conditional statement and its contrapositive will always have the same truth value. So if a conditional is true, its contrapositive is true. Similarly, the converse and its inverse will always have the same truth value. So if a converse is true, the inverse is true. If the inverse is false, the converse is false. Alright guys, sorry this video is a little bit longer. It's a lot of definitions, but thank you for filling it out. I will see you guys in class. Have a wonderful weekend.